Okay, guys, I want to actually talk about, we've talked about converting grams into moles and moles into grams. Now I want to talk about something else. And what you should look at that graphic I gave you, the one that looks like a little pyramid. All right, and what you'll notice is in the middle is moles, right? In the very middle is, okay, let's actually do this a little darker so you can actually see what I'm writing. In the middle is moles. All right? So what that means is that you can always convert things in and out of moles. And at the bottom of that pyramid, you can go from grams to moles. So if you know how many grams of something you have, you can figure out how many moles you have. Or if you know how many moles you have, you can figure out how many grams you have. For example, if you have 2 moles of helium gas, right? And we know helium gas weighs 4 grams per mole, then you know you have 8 grams. Okay. On the other side of that, if you have 8 grams of helium gas, and you know there are 4 grams per mole, that means you can figure out you have 2 moles. So that's one thing. But you also notice down in the corner there's something that looks like this as well. Molecules. All right? And that's where it gets a little tricky, because that's where you have to deal with Avogadro's number. Okay? Avogadro's number is 6.02 times 10 to the 23rd. So say, for instance, I have 1 mole. That means I'm multiplying by 6.02 times 10 to the 23rd if I want to go to molecules. Or if I have 2 moles, that means I have 12.04 times 10 to the 23rd, which then you have to convert into correct scientific notation, and it becomes 1.2 times 10 to the 24th. Okay, you better look up that whole scientific notation thing again. On the other hand, what if I told you I have 6.02 times 10 to the 23rd molecules? Well, how would you figure out how many moles that is? You would divide. Okay? It works the same way with all of these guys. If I know how many moles I have, you say I have 2 moles of water, we know, and I know this out of the top of my head. You would have to figure this out. Water weighs 18 grams per mole. How do I know that? Well, I know oxygen weighs 16 grams per mole. The 2 hydrogens each weigh 1. 16 plus 2 is 18 grams per mole. So if I say, for example, I said I have 3 moles of water, then I know I have to multiply by the molecular weight, and that will give me the number of grams. But if I said instead, okay, I have 9 grams of water, well, then I would have to divide by the molecular weight, which is 18, and that would tell me how many moles I have. Those of you who are good at math in your head, if I have 9 grams of water and I divide by 18, that would be half a mole. And you guys may also notice that on that pyramid there's a third guy. If you have gases under volume, you can actually figure out volume if you have very special circumstances. If it's an ideal gas, which is things like hydrogen or helium or chlorine gas, they're gases that don't have any electromagnetic attraction at all. And it's at standard temperature and pressure, which means the temperature, I think, is 22 degrees Celsius, and the pressure is 1 atmosphere. If you do that, then the constant you're going to measure is 22.4 liters per mole. Okay, so that's what that graphic is all about. So what happens? Suppose I have 1 mole of some Nobel gas, and it's at standard temperature and pressure. Well, then I multiply, and that will tell me the volume. If I have a volume of a Nobel gas, and I want to go this way, well, then I divide by 22.4. That's a constant. That's like Avogadro's number. So that's how that graphic works. All right. So I want you guys, we're going to be using this very shortly to do the other things. I'm going to post this as a separate video because I don't want to have my videos be much more than 5 minutes long. All right. So that's what that graphic is telling you.